Okay, so the first kind of like rule that we're going to learn about for integration is called substitution. So substitution we use when we are looking at something that we had used the chain rule to find the derivative of, okay? So often we identify something as a substitution question because it has a function all to the power of another function, okay? And we see the derivative of the inside function is just like hanging around, okay? So hopefully as we get into this, you're gonna understand what I'm saying more. But there's kind of like a formula for substitution, and basically it's FU du. Okay, so what I wanna do when I'm doing substitution is I wanna find a way to substitute every single integral question so it looks like this. So basically the u is the part that's inside the function, okay? The f is like the outside function, okay? So think about composition of functions. Functions stuffed inside of functions, and the du is obviously the derivative of u, okay? All right, so let's have a look at this. So for this question, when you're identifying a substitution question, what I want you to do is look, is there a function all to the power of something? And see. So I think that u is x squared minus 5 because it is the inside bit. So then fu is saying, what is happening to u? What is happening to u? Well, u is all to the power of 8. So I'm going to write u to the 8. That's what the outside function is, okay? Now here's the tricky part. Basically at this point, I have something I can substitute in for this guy right here. But then I have all this stuff left over. So the next thing I do is I apply d dx to both sides of this. So if I do d dx here, I get du dx equals 2x. So I just apply d dx to both sides of this. So d dx of u is du dx, and d dx of this is 2x, okay? So now I'm going to look at this, and what I want to do is I want to rearrange this so that it's this. Because I want to do substitution. So that's pretty easy. I'm just going to multiply both sides by dx. So I end up with du equals 2x dx. So now this matches this, and it can be substituted with du. So now I do the substitution part. So this whole thing is equivalent to u to the 8. That's that part right there, right? U to the 8 du. And then I just find the derivative of u to the 8, or the integral, sorry, of u to the 8. So the integral of u to the 8 is u to the 9 over 9 plus c. But then I plug back in u, so I plug this back in. So the integral is x squared minus 5 to the power of 9 over 9 plus c. Okay? I'm going to do another example of substitution. We'll do another simple one. Okay. So let's do this one. So sometimes we get traumatized when we see trig involved, but don't be traumatized. What you're looking for when you're identifying a substitution question is a function all to the power of another function. And the derivative of the inside function is hanging around. So right here, this fits the bill because I have a function all to the power of a function, and the derivative of the inside function is hanging around, okay? So what I'm going to do is my u du, remember your u most of the time is the function that's stuffed inside. So my u is 2 plus sine x. My fu is u to the 10. My next step is to find du dx of this guy. So du dx, so apply the derivative in terms of x at either side. The derivative of sine is cos. And my next step is to look and see what I have. So I've already taken care of this piece with the u to the 10. So I need to rearrange this guy so it's cos x dx. Excuse me. So just multiply both sides by 2x dx. So I end up with cos x dx. Okay, so now I'm just going to substitute that all in. So I end up with u to the 10 du. The integral of u to the 10 is u to the 11 over 11 plus c. And then I just plug in u. So 2 plus sine x to the power of 11 over 11 plus c. Okay, so those are basic substitution questions. I'm going to do a trickier one in the next video.